Hello guys, welcome back. Today we will see more important concepts or terminologies of graph theory. Last video we have discussed some important concepts. So I'm just scrolling the above sheets. So last class I explained about graph theory and terminology loop, multiple edges and a simple graph. Today's video I will explain more terminologies. Number 4, adjacent vertex. Two vertices or adjacent or neighbor two vertices or adjacent or neighbor if they are the end points of an edges or endpoint of an edge. For example, let me draw a simple graph with 4 nodes. So A, B, C and D. One more edge connecting D and B. Okay, right. So here A and B are adjacent to each other because A and B are the endpoints of an edge, and here B and C also adjacent. Similarly, C and D and A and D and B and D. But A and C are not adjacent because they are not the end point of any edges, or we can say in other words A and B or A and C are not directly connected to each other. So here A and C is not the adjacent vertex, but AB is adjacent, BC is adjacent, CD is adjacent and DA is adjacent. Also B and D are adjacent to each other. So so this is the adjacent vertex. That means the vertex which are directly linked to each other, or there's a edge connecting the two vertices are called adjacent to each other. And the next terminology, number 5, finite graph. Finite graph. A graph is said to be a graph whose vertex set and edge set are finite. Then the graph is said to be a finite graph. For example, I can draw any shape or any number of vertex and edges. Here I am just drawing a sample graph G. We can say the node is A, B, C, D, and the edges E1, E2, E3 and E4, meaning, and E5, meaning we have the finite number of vertex and finite number of edges we have in the graph. So we can say the graph G is a finite graph. Here the vertex set is A, B, C, D, and the edge set is E1, E2, E3, E4, E5. So the vertex and edges, vertex and edge set are finite. Finite meaning we can able to count how many edges we have, 1, 2, 3, 4, and how many vertex we have, we can able to count. So it is a finite graph. And the next terminology, number 6, is null graph. Null graph, the graph which has the graph which has a vertex set and edge set are empty. So here we cannot give any example because we don't have any edges or any vertex to represent this null graph. So it is just a blank space. So null graph cannot be represented. It is just a blank space, meaning no edges and no vertices. The seventh one is complement of graph. So complement is just the inverse, like how we find the complement of x. Complement is x bar or x dash. So here with respect to the graph, the inverse, the complement meaning the inverse of any graph, inverse of a graph is called the complement of the graph. So here we need to draw the complement graph. For example, I take a sample example of the graph. I have say vertex 1, 2, 3, 4, 5 vertex. Just for the sample, I just taken this graph G. So the vertex is named as 1, 2, 3, 4, 5. So I need to draw the complement of the graph. Step 1. So from the question given, from the graph G, we need to mark the vertex. Is the first step. So I'm just marking only the vertex. So 1, 2, 3, 4, 5. 5 vertices I have just marked. This is the first step, and name it as per the graph G. Now step 2, we need to mark the edges. If there is an edge between any two pair of vertices in the graph G, but in the graph, complement of graph G bar, we need to ignore that edges. So meaning if you find, if there is a edge exists between the pair of any vertices, then do not represent that, or do not mark, or do not mention the those vertex in the complement graph. Example, start from anyone. So start from vertex 1. Here 1, we have the edges 1 to 2 and 1 to 5, right? So here in the complementary graph, we should not draw the vertex 1 to 2. We should not draw the edge from 1 to 2. But there is no edge connecting between 1 and 3. So I need to represent the edge in the complement graph. 1 and 3 no edges, and 2 and 4 no edges, and 3 and 5 no edges in the G, and 1 and 4 also not available. So wherever the graph is exist, whenever there's edges exist in the G, we should not represent in a G bar. So if you keep continuing, you will end up with the representing the complement of the graph G, that is G bar or G dash. So it's just the inverse of the graph G. Let us see another example. So I'm just marking some vertex and some edges. So where I have 5 vertices and I have some edges connecting some vertices. So how to draw the complement of this graph G? First step, mark the vertex. So 1, 2, 3, 4 and 5. First step. Second step, keep marking the edges. If you find a edge between any vertices, then in the G bar you should not mark. So you should make a new link where it is not connected to each other. So here 1 and 3, there's no edge between 1 and 3. So we have marked the 1 and 3 edge in the G bar. And 1 and 2 already available, 1 and 3 also available, 1 and 4 also available, 1 and 5 also available. So 1 is finished. Now go to 2. 2 1 is edge available, 2 4 is not available, so draw 2 4 edge. And 2 5 also not available, and 2 3 already available. Then come to the 3. 3 1 already we have drawn, 3 2 is connected. Now 3 5 is not available, so draw the 3 5, connect 3 and 5. And comes to the fourth one. 4 1 is not available, so 4 1 is connected, so we should not draw 4 1, and the rest already we have the edges. So this is the complement of the graph. Okay guys, see you, have a great day.